Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Muhammad Rafli Syaputra and we are from Universitas Pendidikan Indonesia. On this time we will presentation about our paper. The title is Utilization of Bacterial Interaction using Technology Microbial Fuel Cell through Catalytic Reaction of Microorganism on the pond sludge. Our paper is written by Diva Aulia from Department of Physics Education, Muhammad Rafli Syaputra, myself from Department of Computer Science Education, Putri Andam Widiasari from Department of Mathematics Education, Putri Widiasari from Department of Chemistry Education, but unfortunately, Putri Ayu who was unable to attend today due to unwell. Move on to introduction. Background of the background of paper. The energy crisis has become a world problem, including Indonesia. Indonesia is facing the problem of an electrical energy crisis. The State of Electricity Company, or PLN, which handle electricity problem in Indonesia, is still having difficulties in the problem of adding new power plants developed a lot. Based on this, it is necessary to conduct research on the development of the use of MFC as an environmentally friendly alternative system to produce electrical energy. Then, what is a microbial fuel cell? Microbial fuel cell is an alternative technology that can convert chemical energy into electrical energy through catalytic reaction using microorganisms. While the microbial fuel cell system is a device that uses bacteria as a catalyst to oxidize organic and inorganic substance to produce an electricity current. Move on to method. The material we use is 2 liters of mousse pond, 1 pack of jelly stick, 3.75 liters of mineral water, 58.5 grams of sodium chloride or NaCl, 1 molar. The tools we are using is air pump, U-pipe, multimeter and a set of alligator clips, 2 beakers measuring 1000 milliliters, 1 plastic measuring cup measuring 500 milliliter, 2 copper electrodes, 2 aluminum electrodes, and 2 zinc electrodes. 2 sandpaper, a gas of stove and a pan, 1 wood silk, and 1 cotton pad. Move on, making a salt bridge. The first one is prepare a stove pans, wood silk, U-pipe, jelly sticks, NaCl, and mineral water. The second one is turn on the stove and boil 150 milliliter of water in such pan. The third one, put 2 pieces of jelly stick and 5 teaspoons of NaCl into the boiling water. And fourth, stir evenly for 5 minutes, then drain for another 5 minutes. 5. Put the mixture into the U-pipe using a plastic measuring cup, then allow it to stand until it hardens. 6. Or the last one, place the hardened salt bridge in the refrigerator to make it denser.
Next is a copper, aluminum, and zinc electrode preparation. 1. Prepare sandpaper, copper, aluminum, and zinc electrodes. 2. Clean the electrodes from impurities or biofilm using sandpaper. 3. The electrodes are ready for use in the experimental process. Next steps is diluting sludge using water. First, prepare a 1000 milliliters beaker, stir solid mud and water. Second, pour the solid sludge gradually into a 1000 milliliters beakers. Third, pour water little by little into the beaker, which is already filled with mud. Last, stir the solid mud mixture with water until evenly distributed.
The next is conducting an MFC experiment system. First, prepare beakers, salt bridge, name tags, mud, mineral water, alligator clips, cotton wool, multimeter, HVS, air pumps, pens, copper, aluminium, and zinc electrodes. The second is pour 900 milliliter of mineral water into a 1000 milliliter beaker. Then pour 500 milliliter of the dilute sludge into a 1000 milliliter beaker, and then attach an anode name label on a beaker filled with sludge and a cathode name label on a beaker filled with mineral water, and then put the air pump into a beaker filled with mineral water. The next step is connect the air pump to an electric socket, and then set the multimeter to determine whether you want to measure the voltage or strength of the electric current, and then insert cotton into each end of the salt bridge to prevent mechanical flow, and then put the salt bridge into a beaker that has been filled with mud and mineral water, and then put the electrodes into a beaker filled with mud and mineral water. And the last step is make observation on the MFC system and record the movements of the multimeter for 5 minutes. So this is the picture of the process of conducting an MFC experiment system. The tool on the left is a multimeter. The multimeter is connected to the cable. The cable that is not connected to the multimeter is put the electrode through an alligator clip and then immersed in the microbial fuel cell system. The two glasses, namely the cathode glass and the anode glass, are connected by a salt bridge, namely a U-tube filled with jelly stick. And this is the result of our experiment. The amount of current generated from two pairs of electrodes at various times of the experiment can be seen in top table. In the experiment, in the combination of copper and zinc electrode pairs, the amount of current generated at the end of the experiment was 0.02 ampere. Meanwhile, in the experiment in the combination of copper and aluminum electrode pairs, the resulting voltage at the end of the experiment was 0.02 volts. The amount of voltage generated from two pairs of electrodes at various times of the experiment can be seen in bottom table. In the experiment, in the combination of copper and zinc electrode pairs, the amount of voltage generated at the end of the experiment was 0.32 volts. Meanwhile, in the experiment in the combination of copper and aluminum electrode pairs, the resulting voltage at the end of the experiment was 0.38 volts. So the conclusion is, in this study, the electric current and voltage in the combination of copper and aluminum electrode pairs produce 0.02 ampere and 0.38 volts at the end of the measurement. Meanwhile, the combination of copper and zinc electrodes produce an electric current and a voltage of 0.02 ampere and 0.32 volts at the end of the measurement. Okay, that's enough from our presentation. We are sorry if there are many mistakes, both from our pronunciation and from our presentation materials. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.